Hello, today we are going to speak about recursive algorithm. It's a very important point, but most of people see it difficult. It's not that difficult, so let's see. Okay, let me give you some quiz, some nice and delicious quiz. We have a tart and we want to have a piece of the tart, exactly 1/8 of the tart. So you don't have any measurement device, you just have a sharp knife that can divide any given part into two exactly halves. So let's start from this information. Okay, what I can do, thinking recursively, I can divide the whole cake into two equal halves. Take one of these halves, divide it into two quarters, and finally I can take the quarter and divide it into two eighths, and that's it. I can give you one of the eighths, and this is the end of the solution. So this is called a recursive solution or a recursive algorithm. Each step depends on the previous step. There is a stopping condition. When I find the eighth part, that's it. I stop. Without recursive solution, it was a bit difficult. We have to find a measuring instruments or a measuring means that can help us to exactly measure the eighths, and then we can cut it from the whole tart. Okay, so let's move from eating and tart into some real example. Factorial. The factorial of a number is defined as the multiplication or the product of all numbers from 1 to this number. So factorial of 5, we multiply 5 by 4 by 3 by 2 by 1. It's equal to 120. Factorial of 4 in the same matter, it's 24. And let me tell you that factorial 0 equal 1. Okay, so what we are trying to do now, trying to find a recursive function or a recursive algorithm that can compute the factorial of a given number. So to write something recursively, we have to think of two things: the recursive relation or the recursion relation and the stopping condition. The recursive relation define each item from the previous item. Here we have factorial of n equal n multiplied by factorial of the previous number n minus 1, and the stopping condition when we reach 0, factorial 0 equal 1. So from these two given information we can build our recursive algorithm. So the algorithm or the function written in C or Java, standard C or standard Java, it will be look like this. It's a function called factorial. It has single parameter integer n, and first of all it check if this is the stopping condition or not. If it's not the stopping condition, we just use the recursive relation. It's not the If it's the stop condition, we just return the final value, which is 1. So what's the recursive? How we define a recursive function? The recursive function invokes itself, or it calls itself from one or more point in its body. Okay, let's see now some example of how to compute factorial of 3. We start with calling the function. The function executes the first line and find n doesn't equal 0, so it computes 3 multiplied by factorial of 2. And what of factorial of 2? It calls itself one more time and then try to compute factorial of 2. So this block looks like the execution of the function in the memory, and then we go to factorial 2. Again, n doesn't equal 0, so we We compute 2 multiplied by factorial 1. We try to compute factorial 1. We go the third time into factorial 1. And finally, we have to compute factorial 0, which is the stopping condition. So we just directly return 1. The 1 comes here. 1 multiplied by 1 comes there. 2 multiplied by 1 returns to the function with n equals 3. And finally, we return with 3 multiplied by 2, which is equal to 6. And that's it. So we execute 4 instances of this function. 1 equal 1, 2, 3, and 0, the stopping condition. And finally, we return 6. Okay, so this is the idea of recursive. Let me explore more by giving you these small questions. Okay, why we didn't write the recursive relation in this form? Factorial n equal factorial n minus n plus 1 divided by n plus 1 instead of n minus 1 multiplied by n minus 1. So also, what would happen if we try to compute factorial of minus 1? Which is better as a stopping condition? N equals 0 or n is less than 2? Okay, so I will give you some time to think of these problems, and then we will answer it late. Okay, so let's have some